everyone. On behalf of MS Champs team, I warmly welcome all the participants for the September meetup. I'm Shivani, moderator of today's session. Glad to be here with an exciting panel of speakers today from diverse backgrounds to share their knowledge with us. And please post your questions in the Q&A tab available to you. The questions will be answered by the speakers at the end of their respective sessions. Without further ado, I invite our first speaker, who is Microsoft MVP in Artificial Intelligence, Associate Director Innovation, General Council member in SLASCOM, Mr. Calvin Hill, to conduct the first session on computer vision hands-on with Azure. Mr. Calvin, the screen is yours now.
Thank you, Shivani, for that warm introduction. Is my screen visible?
Yes, Mr. Calvin.
Right, okay. So thank you everyone for connecting for this session, and we'll be taking through a very exciting area, which is computer vision. And I will be covering a couple of areas today under this. So thank you for the introduction. I'm not going to introduce myself again. So we'll be covering a small introduction about what computer vision is all about and some of the industry use cases which computer vision is being used in various type of industries, from automotive to banking and finance, to retail, to various type of areas. And then we'll be talking about what are the Azure services when it comes to computer vision. There's a lot of areas when it comes to cognitive, custom vision recognition. Then when it comes to the intelligent automation side, also there is computer vision such as OCR, face recognition. So we have quite a lot of areas to cover, and we'll be taking through some live demos as well. And finally, we'll be talking about what is the future of computer vision, such as computer vision on edge computing and so on. So is computer vision something new? Not really. Researchers go back to more than 60 years, right? It's not something that was started about 5-6 years back, but computer scientists have been researching in this area for quite a long time. If you look at some of the stats, like initially in 1963, computers were able to transform 2-dimensional images into 3-dimensional. So researchers have been starting from the early 1960s. And then in 1974, the introduction of OCR technology. So nowadays, of course, OCR is being used very much in most of the organizations, specifically in the banking and finance, where they try to automate this manual data into processes, which I'll talk about in a couple of slides. And also in 1982, neuroscientist David Ma established that vision works hierarchically and introduced algorithms. Now, one of the main interesting things is how a neuroscientist, contributed in computer vision, because as you know, artificial intelligence, machine learning, deep learning, all of this, the concept and the inspiration of these technologies is to simulate how a human brain works, right? So as you can see, people from neuro science background also have contributed and try to simulate the cognitive skills of humans through computers. And then in the early 2000s, we saw a lot of technologies such as object recognition. And then in 2005, 2006, you saw, AI exponentially growing in the areas of NLP and computer vision. And companies like Microsoft, Google, IBM have contributed a lot. And even Facebook, right? Facebook AI have contributed a lot to develop this technology to what it is right now. Before we get into what vision recognition is, I think I should give you a background on how vision recognition works. Now, all of us know that vision recognition is a part of AI, but what subset does exactly vision recognition come into? Now, modern day computer vision recognition technologies are built on CNNs. You would have heard about CNNs, convolutional neural networks, deep learning, all of this. But the underlying modern day architecture is done on neural networks and CNNs. So before we get into this, I think some people might be a bit confused because there's a lot of jargon thrown out there, words such as artificial intelligence, machine learning, neural networks, all of this. So before we get into these kind of, um, uh, I would say, technical words, it would be good if I can give a bit of an overview on what are these words all about. Now, if you take AI, artificial intelligence is the umbrella of all of these technologies that fall under. So most of the time you see in the technology space words such as artificial intelligence coming into play. So machine learning is actually a subset of artificial intelligence, and deep learning is a subset of artificial intelligence as well. But the difference between deep learning is that it works with neural networks. You would have heard this. So neural networks actually resembles similarly like a human brain, the artificial neurons. Now, machine learning is kind of traditional, where you use many algorithms, like regression, classification, all of this. There is clear differentiation where you need to use machine learning and where you need to use kind of deep learning and neural networks. But when it comes to computer vision, computer scientists and data scientists have understood that deep learning, neural networks, and CNN are the best approach that you get more accuracy. When you want to develop more accurate models. So, as you know, uh, we call a deep neural network when there are more than three layers, right? So if there is only one neural network, we don't call it a deep learning model. But if there is more than three neural networks, we call it a deep learning model. And I'm not going to talk about now what deep learning model and all of this. Probably we can talk about it in a different session. But as I explained, when it comes to modern day computer vision architecture, deep learning, neural networks, CNN, all of these are pretty much used right now in modern day architecture. And initially, if you look at AlexNet, these are some of the early kind of architectures which were built on deep learning models for computer vision. And some of these, award-winning models, basically, they won certain awards and all of this. So as you can see, AlexNet in 2012, it included 5 convolutional layers and 3 fully connected layers. And if you get into Google's model, so there are different type of models, right? Different type of companies, researchers put these models out, and the latest models that are coming in have better accuracy, have better advantages than the previous models. This is from Google, which has 22 layers. So they play with the layers and the architecture to kind of get the most better accuracy. Now, if you look at ResNet, is being used even today by Tesla for its automotive autonomous driving, basically, which I'll talk about in the future. So as you can see, what I want to give you an idea here is how deep learning neural networks and different type of CNN architectures are being used for computer vision. And these architectures will depend on the use case as well. So one architecture won't fit, it's not a one fit for all use cases, right? Now for autonomous driving, ResNet is one of the most popular architectures, which has been used by Tesla as well. But maybe for face recognition, object detection, different type of architectures are useful. So I like to talk about some of the use cases out there when it comes to computer vision, because under computer vision, there are a lot of areas, like you have face recognition, object detection, OCR, and all of this. So we'll start with one of the most popular one, which is face recognition. So under face recognition, there's face verification, emotion identifications, and many use cases out there, which I will take you through when I'm talking about the Azure services. But if you look at the industry, face recognition is being used in many areas. Now, some of the areas that even the company that I work in, Millennium IT ESP, we work on remote customer onboarding, specifically when it comes to banking and the financial industry. Right now, with the COVID-19 scenario, customers actually can't go to branches, right? Say they want to obtain a loan or a lease, or they want to onboard themselves on a credit card service. Previously, they would go to the bank branches and provide all their photos and NICs and confidential documents, all of this paperwork to the bank agents. But right now, with the COVID-19 pandemic, they can't do that. And not only with the COVID-19 pandemic, if you look at the global trends of, we call it digital customer onboarding or eKYC, video KYC, most of this done remotely. So that transformation is now even happening in our country as well. So the idea of this is that the customer can onboard themselves through the eKYC process remotely. And in this, computer vision face recognition is being used a lot because they need to understand whether this person is the exact person that the information is being uploaded. They need to cross check the selfie image they take against the image that is in the passport or the NIC. Also, there are stuff that we do, such as we call it face liveliness detection and spoofing. So all of this need to be passed before the customer onboard. It's like we call the remote customer verification. And computer vision face recognition is heavily being used here for this kind of use cases. So for example, if I show you some of the example use cases, now say you're a customer, you're onboarding yourself, you will download the bank's mobile application or you will go to the bank's website and you will onboard yourself. So all of these kind of standard features of entering the mobile number, OTP, all of those are fine. And then once you're logging in as a new customer, you will actually go through the remote verification process, which the computer vision algorithms start kicking in. Now here, as you can see, this is what I want to show you. This is actually called the spoofing check. So what do we do by spoofing? Now, the reason for doing spoofing is, say if I want to do some kind of mischievous activity, right? I can take a picture of someone else or record another person's video, and I can try to open, or provide information on behalf of that person, right? So with this kind of computer vision techniques, we can actually identify whether this is a photo or whether this is a recorded video or whether this is the real person. So if this is a recorded video or a picture, the platform doesn't actually allow the customer to proceed, or the platform might throw out a warning message saying, this is not a real picture, right? So it doesn't actually proceed. So these are some of the areas where we use actually computer vision to do that spoofing check in the initial phase. So let's just say now, once the customer onboards, we also do a thing called challenges. So in here, we use computer vision face detection, right? So in face detection, we tell the customer to randomly, look up and down, right or left. And if he has done those according to those challenges using face detection, that challenge will be passed and he will go to the next step. So these are some of few areas that I want to share with, because as we talk about computer vision, you need to understand what are the real world use cases. And this is another use case that in fact we are using some of the Microsoft technologies as well. Now during interviews, as you know, during video interviews, if you do a video interview with a candidate, you probably would, write down their answers and stats and all of that. But we can actually use computer vision and using some of the techniques like emotion detection and all of the sentiment analysis and all of this to kind of understand, how well the candidate is performing in the interview, right? Whether he's confident when he's answering these questions and so on. So these type of analytics can be used to provide insight for the HR people to take proper decisions, right? And that can be according to several questions, how the interviewer asks the candidate and so on. So when you are doing these kind of interviews manually, you can't get this insight. So you can kind of use computer vision to gather these insights, which will help you to understand, how well the candidate is performing. Now, this is another use case which we see in the banking and financial industry, where we need to do a face verification. Now, previously I spoke about face detection, right? In the spoofing and the challenges. Now, in face verification, what we want to do is, say I take a selfie image of myself right now, and I'm producing my picture and a snapshot of my NIC or driving license. Now, as you know, even in Sri Lanka, the driving, probably the NICs have really old pictures, right? Maybe the picture in my NIC, I have the picture which I took about, 20 years back, probably. Not 20 years, about, I would say, about 10 or 15 years back, probably. So that picture, even sometimes I can't recognize, right? So how can an agent recognize it? How can a bank agent recognize it, whether this is the same person from, the naked eye? So this is where we can use face verification. So in face verification, what happens is it analyzes the two images. It will analyze the image. I'll show you this in the live demo also. It will analyze the image which is on your NIC or driving license passport against your selfie image, and it will give a confidence level whether this is the same person. So this is highly being used not only for the banking and finance, wherever you need to know about your customer. So KYC means know about your customer. And when you're doing that remote verification, it's very useful to use this kind of technology. So this is actually, I want to show you another use case in Singapore where they're using face verification to do transactions through ATM. So right now, as you know, most of the parts of the world, even in Sri Lanka, when we need to do a transaction, we need to go and take our debit card, enter the passcode and take the money or whatever. But in this, I want to show you how countries like Singapore are using face verification so that customers don't need to take any cards or anything. They just can go and do the transactions. So let me just play this video for you.
OCBC says it's the
Can you hear and see the video?
Verification at its ATM.
Yes, we can hear the video. We can see it.
You no longer need to carry your OCBC
So just watch this.
ATM card for certain transactions like checking your bank account balance or making cash withdrawals. Let me show you how this works. So now I can check my account balance using face verification. All I have to do is to put in my IC number using this virtual keyboard. And this is where the actual face verification begins. And now I can check my account balances. So if you're wondering how this system managed to detect my face.
So yeah, that was how a kind of small example how banks are using it in different areas. But also if you look at security, face recognition is highly being used in for security surveillance. Now, previously most of the security technology like CCTV, all of the modern stuff come with face recognition. Whereas if you look at the old school stuff, a person has to look at the security screens 24/7, and most of the time we know the security guards are sleeping, right? But using face recognition, we can actually train, say if there is a criminal or a person that we need to identify, we can train that person's image, and then the face recognition engine, whenever the engine spots this and captures this person, it can trigger alerts and notification. So rather than being reactive, you can take proactive kind of measurements for this. And most of the security surveillance technology, they use edge computing. So edge computing, in a sense, now we have the AI models that can run on cloud, like Microsoft Azure, and also you can run some of the AI models on device, right? So most of these security surveillance systems come with kind of on-prem AI models, which you call edge computing. So I just want to show you this video as well, how China is using face recognition for its security and surveillance?
Well, let's see how long it takes you to find me. Thank you very much. Let's go.
我们可以追溯到说，出现每一张脸都可以对应说他的身份证，以及他所经过，比方说在过去1周，我们回溯他的行经路程，我们也做了像人和车的匹配。那同时在人上匹配还包括亲属关系匹配，然后是你经常接触人员之间匹配。就是当摄像机布到或者我们传感器布到一定密度的时候，其实我们会经常知道你跟谁今天在一起。
Well, here we are.
So, it's quite scary, right? The level of kind of surveillance they do, which is kind of questionable sometimes as to the privacy that people have. But as you can see, these technologies are being used in governments, in banks, financial institutes. Another interesting use case that the entertainment industry uses this is if you go and research some movie production companies, they actually, before they release the movie, they do a pre-release with a selected set of audience, and they use the visuals of the audience reactions, right, for different parts of the scenes, whether when there's a kind of a exciting scene or when there's some action happening, how the audience react, whether it's positive, negative, or whether they're confused or angry, and they use those kind of statistics to make decisions and to change their script and to rewrite them and so on before they produce the final production. So various type of industries use face recognition. So we talk about face recognition and we're coming to object detection. So under object detection, it's about how computers can look at the objects out there in the world and the space and identify what these objects are, their densities, the kind of the locations they are, and what are the kind of objects these are. So I think when it comes to object detection, I think in modern computer vision, autonomous vehicles are pretty much, very much using computer vision to drive their cars automatically. And in this space, if you look at computer vision in the industry of autonomous driving, there's a debate as well, because some of the manufacturers and some of the companies say that they can do it through pure vision recognition. That means without any sensors, through the car's cameras. Now in Tesla, there is about 8 cameras around the car, and it feeds in visuals, and according to that, the vision recognition modules are trained and it takes decisions. But some companies and some experts say that only through vision recognition it cannot be done. So they use technology such as LiDARs. So LiDARs are sensors actually which emit light, and they map a kind of 3D space about the surroundings. Now I want to show you kind of a cool thing. I don't know whether you watched recent event of Tesla. It's called the Tesla AI Day. I would highly recommend you to watch it because it's actually groundbreaking, the type of work they do in computer vision. Now they even released one of their own supercomputers, which is called the Tesla Dojo, which runs some of their high-tech algorithms related to vision recognition, decision making, and all of those. So I want to show you a couple of video clips of how next level of things are happening in computer vision, because in computer specifically for autonomous driving, it's not like you're capturing one 2D image, right? It has to have accuracy at least about 99, not 99. It has to have probably about 99.9 accuracy, right? Because you're talking about the car driving alone, and safety is the number one aspect here, and there's a big risk. So how companies like this are making autonomous driving and self-driving a reality. Something, about 15-10 years back was just science fiction, and how they're using visuals, how they're using they're using techniques like vector mapping. So what they're doing is they're taking visuals from all of the cameras on the car, and the car has its own brain, and it develops a 3D map, and it takes decisions according to that. So to do this, they feed, simulations of roads, traffic in different parts of the world, in America, in other countries as well, and they feed this engine, right? It's like training a person. So they train all of these situations. As you know, when you're driving, things can happen suddenly, right? So the car needs to react to that. So let me just play this video, which is quite fascinating. Let me try to give you a small overview on what these guys are working on. And I highly encourage you to watch this.
Hi everyone, welcome. My name is Andre, and I lead the vision team here at Tesla Autopilot, and I'm incredibly excited to be here to kick off this section, giving you a technical deep dive into the Autopilot stack and showing you all the under the hood components that go into making the car drive all by itself. So we're going to start off with the vision component here. Now, in the vision component, what we're trying to do is we're trying to design a neural network that processes the raw information, which in our case is the 8 cameras that are positioned around the vehicle. And they send us images, and we need to process that in real time into what we call the vector space. And this is a 3-dimensional representation of everything you need for driving. So this is the 3-dimensional positions of lines, edges, curbs, traffic signs, traffic lights, cars, their positions, orientations, depths, velocities, and so on. So here I'm showing a video of, actually, hold on. Apologies. So here I'm showing the video of the raw inputs that come into the stack, and then neural network processes that into the vector space. And you are seeing parts of that vector space rendered in the instrument cluster on the car. Now, what I find kind of fascinating about this is that we are effectively building a synthetic animal from the ground up. So the car can be thought of as an animal. It moves around, it senses the environment, and acts autonomously and intelligently. And we are building all the components from scratch in-house. So we are building, of course, all of the mechanical components of the body, the nervous system, which is all the electrical components, and for our purposes, the brain of the autopilot, and specifically for this section, the synthetic visual cortex. Now, the biological visual cortex actually has quite intricate structure and a number of areas that organize the information flow of this brain. And so in particular in our...
So I'm going to stop just right there because with the interest of time, but I really encourage you, if you can watch that keynote, you can imagine the kind of innovations they are doing around computer vision. As you can see, they also use neural networks and then CNN and RNN kind of architectures to develop this. But I think there is much more that they do just than standard vision recognition, right? They do a lot of new stuff. So I would kind of encourage you to watch that. But I just want to show you how they look at the car as a biological kind of synthetic being, right? Where the car has the cameras and it has its own brain. It captures visual and it takes decisions, which is amazing. So we spoke about face recognition, then we spoke about object detection, and then now we come to OCR. So in OCR, optical character recognition is being used in a lot of areas around hyperautomation. So if you don't know what hyperautomation is, it's about how you can use technology to kind of automate the repetitive kind of boring tasks in your day-to-day activities in a business, right? It can be simply, looking at a manual document, and so as you know, in day-to-day businesses, specifically in banks and other financial institutes and other industries, there's a lot of documentation still going on, right? Even though most of the things are digital. So there's a lot of repetitive work where documents have been signed and then looked at, and then those information are either entered into a system. So how we can use OCR technology to kind of automate this. And not only that, now even I spoke about a kind of remote onboarding, right? I spoke about remote onboarding where we use face recognition to do this, but also we use OCR technology to make kind of life easy, because when the customer is taking a picture of the NIC passport or the driving license, we can use OCR to put those information and auto-fill them, right? That will kind of make life easy for the customer when it comes to customer experience, where he doesn't know to look at that, enter that. So this is actually how we capture information from the driving license, how we kind of train models to capture information from Sri Lankan driving license. So let me just take you to that exact position. So here the customer can actually upload the driving license. And as you can see, once you upload the driving license, we are actually using Microsoft technology here for the OCR. The OCR will automatically pick the information from the driving license and automatically enter them. So that will kind of make life easy for the customer. Similarly, we have the module for the passports as well. When he takes a picture of the passport, automatically computer vision OCR takes into the picture and takes the value out of it and fills it for the customer. So not only that, now when it comes to situations where you have a lot of manual documentation that is happening. Now, in a scenario like this, I will take you through some of these tools after this. So this is actually how we use the AI builder from Microsoft's Power Automate platform. Now, say in a scenario where companies get a lot of manual invoices, right? Where they need to, the invoice is printed and they need to kind of enter those information to their ERP or whatever. So here we use kind of computer vision technology, as you can see, to train on the invoice. So you can just drag and drop the fields and train, okay, this is where the pricing is, this is where the pricing table is, this is where the address is, this is where the invoice number is. And when you train it on top of this platform, which is the Microsoft Power Automate AI Builder, the next time you feed in a scanned copy of the scan image of the invoice, it automatically picks the information and enters it to the applications, which will kind of make life easy for this automated kind of repetitive task. So what I want to show you here is how OCR technology is being used in this hyper automation kind of space, where we're trying to automate repetitive work, such as when we're trying to digitize from manual documents to applications. Right. So I wanted to give kind of a high-level overview of the kind of use cases out there. There are much more use cases, but I just want to highlight you some of the important ones and the significant ones. So with the interest of time, we'll get into the Microsoft Azure Computer Vision. So under Microsoft Computer Vision Azure, there are a lot of services which they provide, from cognitive, form recognizer, custom vision recognition, video indexer, Power Platform, so on. So if you look at cognitive services, there are many services under this, and under custom vision recognition, like object detection and classification and tagging and so on. So we'll go through this some of the platforms in a kind of live demo. So let me share my browser. So let me just go to my browser. So is my browser visible?
Yes, sir, your browser is visible.
Right. So for you to kind of get into the Microsoft Computer Vision services, you just can go and search for Microsoft Cognitive Services on Google, and this page will come up. And as you can see, under Cognitive Services, there are many services here for decision, language NLP, speech recognition, speech to text, text to speech, and also vision recognition. So the idea of cognitive services is to actually take out the time-consuming task of training and developing the models on your own, whereas it provides you pre-trained models where you can consume by APIs. Now that's why I wanted to kind of give you an overview of computer vision before I come into this, because if you come into this and you start using these services, you might know how this works. But Microsoft makes it easy for us with their Azure cloud services, where they already have the deep learning neural networks trained. We can simply use these services and quickly make our applications intelligent. Now, if you go to the first category, which is computer vision. So under computer vision, you have many services like OCR, image understanding, spatial analytics, all of this. Now they have given some use cases here as well. For example, if you take this image, as you can see, once you feed in the image, right, and you consume this API service from the cloud, it automatically gives us the tags. You know, as you can see, there's a person here, it's a subway, and so on. Now, if you take, for example, if you feed in this image, you can see there's a lady here, two ladies, and a person, and there's a laptop. As on your right hand side, you can actually see how the kind of computer vision recognition is extracting the information out of this. So like I said, now if you are going to develop this on scratch, right, you have to train this with data, and you have to build your models. Maybe if you are using, you know, different type of technologies, right? But here everything is done. It's done for you. You just need to consume a service. So not only like object detection when it comes to OCR kind of technologies, as well as you can see handwritten text extracted. So how do you use these services? Now, before you use these services, I also want to mention things about privacy, right? Because since we are using a cloud service, most of the time when we are trying to use cloud AI services, most of the companies and businesses, okay, ask where are the images going? For example, if we are going to use vision recognition on, let's say, a bank's customer, the bank is going to ask us, where is this information going to cloud? So in that scenario, the kind of compliance and the data privacy is very important. So if you go to some of the questions asked by most of the customers, as you can see, if you go to this, do you store the images, videos in computer vision, and you go to this privacy link, you can see the compliances. So as you know, there's compliance like GDPR and PCI DSS. PCI DSS is specific much to the financial banking and financial industry, specifically related to customer confidential information. Now, if you are deploying these kind of services, you need to have that PCI DSS standards, and Microsoft pretty much has all the standards here, as you can see for computer vision, Face API, all of this. So it's very important when it comes to the privacy factor, because if you are developing, let's say, an app or another application which consumes computer vision from Microsoft, most of the customers will ask, okay, where is the images or the visuals going? Is it stored on cloud? Okay, what is the kind of compliance that this cloud services has, and so on. And also, you need to know that when you're consuming this computer vision, how this is going to charge, right? Because end of the day, when you're building a solution, right, for a customer, you're giving it as some kind of pricing. You need to know that if you're consuming certain computer vision services from cloud services, not only from Microsoft, it can be Google, you know, it can be AWS, all of this. This pretty much has the same kind of mechanism, pricing mechanism, which you call platform as a services, pay as you go. So it's all according to the how much of API calls you call. So if you go to the pricing, you can see most of the time you need to select like South Asian region because of the latency, right? Because the data centers are close by. And if you look at the pricing tiers, there is a free tier and there is a different type of tiers with a number of API calls. And these are pretty much very viable pricing. If you look at 1 to 1 million transactions, this is the amount of dollars that will cost. So for example, you need to, when you're pricing your solution, you need to kind of understand, for example, if it's a customer authentication application, how many customers might authenticate your app in a day, week, or month. And according to that, you can do your pricing calculation. And when you're doing the pricing calculation, you can go to the Azure pricing calculator, add your services here. For example, if you're adding cognitive services, right? Under cognitive services, you can see all the services here. Now, since we're talking about computer vision, specifically talking about Face API, and you can provide the basically the number of transactions, I mean API calls. So that API calls you'll need to understand when you're doing the requirement gathering from your customer and so on, right? Just want to give you that overview. But how quickly we can start one of these. So if you have, obviously you must be using Azure. So if you're logged into Azure, if you want to quickly consume computer vision into one of your applications, you can simply go and search computer vision. Right now, I have for this webinar I just created already. And once you search computer vision, you just need to create that resource. And once you create that resource, which I already created, the most important thing is to understand your keys and the endpoints. This is what you will be using in your code to call this REST API service and get a JSON output basically. Now to show you a small demo, I just done a small code here. Let me just share you some of these images that we are going to kind of analyze. So one thing that we want to analyze here is the face detection, right? So let's just see how we're going to do it. Before that, I'll just show you the code as well. Right. Hope my screen is visible.
Yes. Sir.
So this code is actually there in public as well. If you go to the Microsoft vision recognition and you go to GitHub, this code is public as well, right? This is not something that I had done on my own. But if you can see, the most important thing here is once you get those keys and the endpoints, you need to establish them here. And in the first kind of demo, we can see the face detection, right? So let me just show you the image that we're going to detect. So again, let me share my screen. So this is the image that we're going to detect. We're going to kind of get outputs of this image. So when you basically run this and pass this image, right? You will see the output. So let me just run this. My screen is visible, right?
Yes, sir, your screen is visible.
Okay. So as you can see, when I run, this is actually, I'm running this on Node. So as you can see, when you run this, you get all the kind of characteristics out of this image. Now, remember, I showed you the image, it gives the age, it gives the gender, and it gives the location as well. But going down, added more images here for object detection. In the object detection, actually, this is image with the dog, right? So it gives the output. So as you can see, this services is very easy to use because you're, just consuming the REST APIs and you're getting everything out of it, which makes your life easy, to be very honest. So these kind of services are made to make the development process and make, AI enabled application development more agile, because if you need to do this from ground up, it's going to take you a lot of time. So simply consuming a cognitive services like this from Microsoft will kind of make life very much easy for you. So if you look at another thing, there's quite a lot of things that I had done here. Now, not only the face detection, but also detecting tags. So here in detecting tags, we can actually identify different type of objects in image, right? There is a mammal there or a dog there and so on. So in computer vision API, you're not only getting face, but you're getting all the other services as well, as you remember, the OCR, the object detection, and even the kind of recognition, other features like, for example, the brand recognition. Now in this image, there's a specific image which has the Microsoft logo embedded in it, and it's identified the brand as Microsoft. So many other kind of inputs that you can get out of here, like the color tones, the color schemes, and all of those, right? And also there's a thing for adult content kind of recognition. If you have any adult content in videos and images, you can actually filter those out. A lot of these streaming services are using this basically, right? So basic kind of idea that I want to show you how easy it is to consume this service, and you pass the image and you get the responses, right? So I think since we are running out of time, let's go through the other ones. So under computer vision, so we spoke about, yes, computer vision. And then if we go to face API, now face API is very much there are two kind of face API techniques here, one which you call the face verification and the face detection. So face verification is mostly used to identify whether this is the same person, the exact use case which I told you. And face detection is to understand whether there is a face. Now face detection is being used heavily when it comes to CCTV, security surveillance and all of this. But these days we have seen a lot of use cases where organizations and even governments want to see whether the people or the employees are wearing the mask, right? If they are not wearing the mask, they can kind of notify them and so on. So in face verification, as I told you, they want to verify whether this is the same person. Now, for example, let me just try to submit a kind of image and show you how this works. So I'm going to submit my self image, and I'm going to submit actually my. So as you can see in this scenario, it takes as the person is different. Don't laugh about my NIC, right? These pictures are taken so long ago. But as you can see, even if the image is small or the image is not clear, the face verification technology is very much able to say that this is the same person or not at this confident level, right? Which is really good. And if you want to kind of learn how to deploy some of the quick deployments, even in face verification, you need to go to your Azure portal and search for Face API and create that instance. And remember to make note of your endpoints and the keys. This is where you will be using them in your code, right? And if you go to face verification, there are enough and more kind of sample code snippets on the Microsoft official page and also GitHub as well in different coding languages. Now, the previous one which I showed you is JavaScript, but there's on C#, Go, or REST API. If you want to just test it through Postman or something, you can use that as well, right? Now, moving on, when it comes to custom vision, now the previous services I spoke about is all pre-trained stuff. Like Microsoft has done the most hard work for you by training this on millions of data, right? When it comes to face recognition, OCR, all of this object detection. But now, if you want to train something on your own, let's say you want to train a kind of vision recognition module in your factory, right? Now, some of the good use cases that we have got is most of these factory, the defects. Let's say it's a manufacturer that is producing porcelain products, that's cups and saucers and all of this. So during the manufacturing process right now, most manufacturers, they put people and they manually look at it and see whether the cup or the saucer is damaged or the plate is damaged or the vase is damaged or whatever. But if you have a custom vision recognition model, you can train that vision recognition engine with the damaged stuff, right? You train with the damaged stuff and you run that model on a camera, then the vision recognition will pick the damaged stuff on its own. So those kind of scenarios, you can't use the pre-trained cognitive services. You need to develop custom vision recognition. So custom vision recognition is all about how you can train your own models, but Microsoft makes your life easy with a kind of low-code, no-code platform. So low-code, no-code platforms are platforms that enable non-technical business users or let's say citizen data scientists to build AI models quickly without writing any code. So if you go to this custom vision recognition model, now I had kind of done 2 demos for you. I did a kind of a classification model on this. In this classification model, I just want to look at the difference between whether this model, if I train it, whether it can identify a Ferrari and a Tesla. So let's see how I had done this. So let me just log me into this workspace. Right. My projects are loading. Right. So in this, the only thing that I did was I actually uploaded a couple of pictures of some Ferraris and Teslas, and I tagged them. Now, if you go to this image, you can actually just tag this image. I had tagged this as a Tesla. Now just see how easy it is, right? For you to develop a custom vision recognition model, you can just upload all your images and just tag it. And likewise, I had tagged it as Ferrari and Tesla. Now, shall we try one and see whether this is working? So if I do a quick test, right? If you want, another thing is I want to see your performance, right? Now, actually, when you're doing a performance checks, it says that you need at least 50 images for your thing to be very accurate. Right now, for this demo, with the interest of time, I just uploaded about 6 images. But remember, the more images you have, the more accurate your model is going to be. So let's just do a kind of test run and see whether my model is accurate, right? Right. So let's just Google Tesla and see. whether my model will pick this properly. Let's just take an image that I have not used before, probably. Let's just copy this image URL and go back to my custom vision recognition workspace, and let's see what it gives. Yes. Here, as you can see, it's giving the wrong thing, right? Ferrari. I'll tell you the reason for that, right? Because we have used some of the images, the color coordination of the images. There are some Ferraris which are white color as well. So as I told you in the beginning, the more images you put here, the more training. Others going to get confused. Let's try something else and see. Let's try something that I have not used before. Maybe this. Let's see. I don't know what kind of results it gives me. Let's just see what it gives. Right. In this scenario, it tells that there's a 50% chance it's a Tesla, but there is a 40% chance it's a Ferrari. Here also the reason, because I have uploaded images of a Tesla and a Ferrari with the same color, right? So the model is kind of getting confusing now. Let's try to search about a Ferrari, right? Shall we upload? Shall you upload this? I don't know whether I trained this image previously. Let's test it out and see. Yeah, it has a 99.1 accuracy of a Ferrari because the color is also there and the design. So most important thing is more data, the more kind of accuracy you will get out of this. Now, once you do your model, you can actually look at the performance, you can look at the prediction, and once you develop your custom vision recognition model, the only thing that you need to do is publish this. Once you publish it, you can consume it as a REST API, right? So just imagine how easy it is for you to develop that custom vision recognition model. And also when you go to settings, as you can see, there are kind of domain specific areas as well. If you are training images related to food or retail, landmark, or products and so on. And there are two things, right? Multi-class and multi-label, right? A single tag and multi-label tags. Let me go to the other kind of project that I did was the object kind of detection model. Here, what I did was I trained with a couple of images and I trained the custom model to identify the Apple's logo. Now, if you go to this, see, as you can see, I have trained this to identify the logo. And likewise, you can actually drag and drop it, right? Now, for example, you can just drag and you can just tag it and you're training the model just by doing that. And if you do a kind of testing, let's just say Apple, okay, Apple Mac, and let's take a picture of Apple Mac and see. Let's just take something like this and see. Right. Let's say whether it can identify. And as you can see, it can identify the Apple logo with a probability of 20%. As you can see, the location also it's identifying at a different location because when I was training the model, I only use the Apple iPhone and specific the logo. Here also you need to kind of upload various type of images to get the accuracy more better. But you kind of get the idea how easy it is to do this, right? I mean, just by uploading a couple of images and you can train them and you can then consume the APIs to in your maybe applications and so on, right? So then we spoke about custom vision recognition, all of this. There is a couple of more services that I want to talk about, which is called the video analyzer. Now, video indexer is also kind of uses vision recognition technology on video to extract information about video. Now, for example, you can go to videoindexer.ai and let's kind of play a video, I would say. Yeah, let's play this. This is one which is already in Microsoft. So the idea of this is while you're playing a video, you can extract information. You can extract the people in it. You can extract the kind of sceneries, the emotions, everything out of the video. So this not only uses vision recognition, also it uses speech to text and NLP and all of that, because the entire video, whatever people are speaking, it kind of translates them and it extract this thing. So as you can see, while this video is playing, you can see the labels, right? It says outdoor, and see all the kind of visual labels and tags have been extracted out of that. And if I go to that specific location, it will take me to that specific location and it will show in the timeline what are the areas. Even the locations of it's predicting that's even it's in Australia, right? And the brands, as you can see, it talks about Android, GoPro, and all of this, all taken out of the vision recognition, and also the emotions of the people, right? Whether it's happy or sad, and the scheme. So all of this are running from the vision recognition algorithms, and also not from that. It also uses like speech to text, right, to extract and kind of extract the text out of the conversations, and you can actually drill down to each of those conversations and so on. So these kind of things have been used in a lot of the entertainment and media industry, because when they want to when they have a lot of visuals, one of the key problems when you are having a database or a storage of a lot of videos, and when you want to search a specific video, specifically just think, for example, like a news broadcasting company, where they have so many visuals that are saved, and they want to take bits and pieces and create a new video. I mean, manually going through those videos and searching them is pretty hard. But you can have algorithms working like this. They can kind of classify all the visuals and those specific segments, and then you can search through them and then kind of segment them and classify them and use your timelines that you want in your specific videos. So then also I want to talk about we talk about Azure video indexer. We spoke about cognitive services, face, vision recognition, object detection, and custom vision recognition. And then we're coming to actually the Power Automate. So I spoke about Power Automate. In Power Automate, it's all about Hyper Automation and RPA. In that also, you have a lot of vision recognition services under AI Builder. So under AI Builder, if you go to AI Builder, the kind of demo video I showed you about how you can customize, custom train your invoices and OCR kind of technology to build, automation, intelligent automation techniques. So I don't think we have time to do a demo for this, but if you go to Power Automate and you use a kind of AI builder for OCR and classifications and vision recognition, you can enable your automation to be more intelligent, right, for the repetitive work. Right. What else can we talk? Also on Azure Stack Edge. Now, when you're talking about computer vision, most of the stuff that I spoke about are running on the cloud, right? You consume services, you build all your models on cloud. But there are instances where probably in a factory or a manufacturing kind of use case, you can't run these models on cloud. You need to run it on-prem in your factory. So this is where you can use the Azure Stack services, or we call it Azure Stack Edge, where they provide you the kind of facility to bring down these same kind of services on-prem. So Azure Stacks provide you a different type of services where you can, run your NLP models, you can run your custom vision recognition, face recognition, all of these on-prem. So these are pretty much used in various type of scenarios. They are probably, connected to a cloud, and also that data residency where you can't upload data onto the cloud. You need to have all of this on-prem. These kind of services will be very useful. And if you go to some of the services which are available on Azure Stack, let's just see whether I can find that for you. Right. If you go to the machine learning services here, let's see, trying to kind of find what are the services that are available under this. Right, this is about the hardware. Okay, I can't seem to find this. Let's see. Implementation. Right. Probably I will share this in another webinar. I just want to show you what are the services that are available. So as I remember, the natural language processing service is available. The computer vision services are also available on Stack. So you don't need to actually consume a cloud service for this. So right. I tried to cover pretty much all of these areas which Microsoft provides on the vision recognition technology. So if you already have Azure Access, I mean, they provide a 30-day trial as well, right? If you put your credit card, I think a $150 consumption, you can easily access these services. So without further ado, I think with the time constraining, I would like to end my webinar here. And if there are any other kind of questions, I would like to take them. Thank you.
Mr. Kevin, there are some questions in the Q&A tab.
Okay.
The first question is, in Azure Computer Vision, can we provide our data sets to train a model?
Yeah, so if you are using cognitive services, like face API and object detection, those are all pre-trained stuff. But if you want to train your own data sets, one is you can use custom vision, but custom vision recognition is not good for all the use cases, right? They are good for object detection and classification, right? But also, if you use services from the form recognizer, all of this, you can use your own data. So custom vision recognition and form recognizer. Form recognizer is more into the OCR, where you train the models on your own documents. For example, different companies have their own invoices. So you need to train your OCR to identify those localized invoices, then you can use that. So custom vision recognition, also you can train your own data, like I explained, for a scenario that you want to train on your own data. So there are features available for your own data sets as well. But if you're looking for a very specific now for custom vision recognition, I don't think it's good to use for kind of medical purposes where you want to kind of distinguish whether the level of cancer and stuff like that. I don't think it's much strong for that, but straightforward services, it might be strong, I guess.
So the next question is it support language like Sinhala in Azure OCR?
So right now it doesn't support Sinhala, but if you go to the OCR technologies, I think it supports the most popular languages from French to, I think, India, some level of Tamil, the Indian Tamil version it supports, but right now I don't think it supports Sinhala OCR. As for my knowledge, I don't know whether there are any developments happening, but recently even we checked for some of our solutions, it doesn't have the capabilities as of now.
So the next question is, what is the edge computing?
So edge computing is something like this. So now some of the services I spoke about of cognitive, custom vision recognition, all of this run on the Azure cloud. So you build your models on cloud, or you train your models and you consume it through a REST API. Edge computing is actually bringing those same capabilities on-prem without consuming a cloud. So edge computer can be a device, even a Raspberry Pi, right? You run a maybe a OpenCV model on Raspberry Pi. That's kind of edge computing. So edge computing is all about bringing those AI vision recognition capabilities into the device itself without need to consume it through cloud services through internet, right? So to facilitate that, your device also has to have some kind of characteristics to run these kind of models, right? So, but nowadays I have seen even in Google, like in TensorFlow, right? They have this TensorFlow JS, and all of these models now being compressed in a way that you can even run it on a browser, right? Some of the AI capabilities and so on. So edge computer is going to be a very important factor when it comes to IoT and all of these areas, I would say.
So the next question is there any difference between the cognitive service cloud and the containers?
Cognitive service cloud and the container. So right. So it's like this. Now, cognitive service, if you're talking about cognitive services, as I explained, these are predefined stuff, right? We don't have the access to their containers or VMs or anything. We just need to consume those services and take them through API. But if you're talking about containerization, I think then you need to work on your own machine learning services. For example, if you go, Microsoft has a separate service called Azure Machine Learning Service, where you have like Azure Machine Learning Studio. That is also, they provide a kind of drag and drop mechanism to build your own models, and you can drag and drop the algorithms, the data training, engineering, all of that. It's made easy. But if you want to go into the kind of containerization method, you might need to use the Azure machine learning services and write your own kind of models on notebooks, like on Jupyter notebooks and so on, and then host them on containers. So I think Microsoft provides all of these services, right? One is they provide the kind of pre-trained models, which you can consume by API. Then they provide the custom vision recognition through low-code, no-code. They provide the ML Studio for drag and drop, and they provide the containers to deploy your own models as well if you want to write your own kind of models through Python or something on notebooks, right? Yeah.
So that's the end of the questions.
All right, thank you. I hope I gave enough of more insight with the limited time. So thank you for this opportunity, everyone. Thanks a lot.
Thank you, Mr. Calvin, for a great session. Gaining knowledge is the first step to wisdom. Sharing it is the first step to humanity. My sincere gratitude to our guest speaker, Mr. Calvin Hindle, for a valuable session. I really appreciate the time you spent with us, and special thanks for the participants for your patience.